Hello and welcome to another tutorial in Unity. This time we're just going to have a wee look at UI and how we can start implementing the fundamental elements of our UI into a system within Unity that reacts to changes in resolution and other various different things that are sort of thrown its way. We're going to have to create a UI, and whenever we do this in Unity, we're going to go ahead and right click in our hierarchy. And just like we would create a 3D object, like a cube by default, we're going to go to UI, and we've got all these different UI elements that we can create. We're going to go ahead and choose Canvas. So Canvas is going to be our starting point for our entire UI. And very quickly you can see, if we scroll out on our Canvas system, that our canvas stretches out across the game view. Now this is a bit strange because it isn't actually in our game view, but this is how we can view the overlay. The next thing we're going to want to do, so that we have a bit of a point of reference, is right click on our canvas and create a new UI element. This time I'm going to choose an image, and now we can see we've got a big old white square in the center of our screen, both in the Unity scene within the canvas, and also now in our game view we can see the square that is being rendered in the canvas system. If the image is not a child of the canvas, it won't show up. It needs to be a child of the canvas for it to sort of process through the parent canvas elements, and you can see all of these different elements of the canvas object here. We've got our canvas components, the canvas scaler component, a graphics raycaster, and then the image has a component as well to display the image. Here's a top tip for you. If you're looking at, for example, a 3D object that's in your scene, like this cube, and you're like, okay, so I've got my canvas, where is it? One of the things that you can do is whenever you select an object in Unity, you can go ahead and press the F key, and that will focus on that particular game object. In this case, we can zoom way out by pressing F with our canvas selected, and now we can see exactly where the canvas is as this big massive part of our game scene, but really this is just an overlay. I'm going to go ahead and move my image across to the top left hand corner of our canvas element. And you can imagine that we are now starting to section out the different parts of our UI, our heads up display overlay, into the different elements that we will require, like perhaps we want a map, perhaps we want a quest marker, health bar, these kind of things. It's important to also note that it's possible to be looking at your canvas from the opposite side. For example, here you might be looking at your canvas and thinking, oh, this is very strange. My white box is in the top right-hand corner in my scene view, but it's in the top left-hand corner in my game view. And so that is because of a mismatch between the perspective that you're looking at in the scene view and the perspective that you're looking at in the game. So you want to make sure that you match those up. And another nice tip for navigation in Unity is if you hold Alt, your Alt key, while you're looking at a particular object, then you can drag your, let's see, what can you do? Let me try this again. If you hold Alt, it doesn't appear to be working. Very strange. Maybe it only works on a cube. Let me see. Yes, if you hold Alt and then hold down your left mouse button, then you'll rotate around that object. So I wonder why that's not working for the canvas. There it is. It's working now. Very strange. I'm not sure what was going wrong the first time, but you want to hold Alt, hold down your left mouse button, and you can rotate around the object. So yes, the point was make sure that you're not looking at your canvas from the wrong direction. All right, so this canvas you can see the outline of based on the resolution of our game. And you can see that if I go ahead and drag this screen across, we're changing by dynamically changing with this free aspect mode on. We're dynamically changing the resolution of our display. And whenever we play the game and we have maximize on play, the resolution will also fill up the whole screen. But we have sort of a problem here, which is that as the canvas changes size, we wish for this box, let's say this box was to represent a UI element like the minimap, we would want it to sort of stick in the corner of the UI rather than at the moment if we put it in the corner now, but then we resize our canvas, oh, now it's off the side of the screen. So the way that we do this and we format our UI is by using anchoring and this rect transform. The rect transform component here that you can see is a UI version of the normal transform component, which would normally contain an X, Y, Z position, which is just where that object is in 3D space. But in 2D space with our canvas object, we instead have a couple of more parameters like width and height, and also anchor points. We can set these anchor points automatically by using this little gizmo here. If we click on this, we can see there are a couple of different presets that we can select from for our anchor points. We can anchor the image to the center. We can anchor it to the top left, the top right. We can also have the image automatically scale left and right and so on, and any combination therein. So for this image, we want it to be connected sort of to the top left-hand corner of our canvas. So we want it to be anchored by clicking on this particular option. And what that has done is changed these anchor position values, but it's a sort of a preset that allows us to select and easily understand our anchor points without having to directly change these values. Now, whenever we change the size of our resolution, so if we drag this up and down, or we maximize on play, the relative distance between the object and the sides of the screen will be retained. So for example, it doesn't matter how much we move this around, the border, the gap, the padding as it were, between the side of this square and the side of the screen will always be the same, the top and the bottom. And another way that we can change the resolution to test this out is, instead of using free aspect, we can set the resolution and the aspect ratio of our game directly. Alright, but look, we've got a new problem that we need to try to fix. At the moment, whenever we change the resolution's aspect ratio, we have the retained position, but the scale is a bit strange. If we have a very high resolution, the little mini map is very tiny, and when we have a very low resolution, the mini map becomes exponentially larger. What we want to do is go to our canvas component and change our canvas UI scale mode from constant pixel size to instead scale with the screen size. With this particular variable set all the way to width, the width of the resolution, if we go back to free aspect, will change the size of the UI element. And we can change the reference resolution here by clicking on the X value and dragging it left and right. The higher the reference resolution, the smaller the object will scale. And that is the case for all of our UI elements. So I'm going to go ahead and duplicate this UI image. We're going to put it into the top right-hand corner, which means we're anchoring it to the top right as well. We can't forget to do that. Then we're going to drag it over here. And now whenever we scale the reference resolution X value, we can see our UI elements are scaling nicely. So we can sort of decide roughly what size our UI elements should be relative to each other in the screen, and then no matter what our resolution is, if it's 1920 by 1080 or if it's a very low resolution, the objects will be sort of fairly similar scale to what they were in a different resolution. Alright, so we can start to create a sort of basic block out for our game. Perhaps we want a health bar. Now, one thing I would say is that you'd be tempted to immediately scale this health bar on the y-axis, for example, like this. I could scale this like so, and this is what you would do for a normal UI element. For a normal game object element, is you would scale it using this X, Y, and Z. However, because the UI uses this rect transform, it's generally a good idea never to change the scale of your object, but instead change the width and height of your object, and I'll show you why in a moment. We have these new properties, width and height, which we can change to instead make our object thinner and thicker. And this will allow the object to sort of run this scaling through the UI system and through the canvas. So now whenever we resize, we can see everything's still working very nicely because we anchored this to the top left. Let's anchor it to the top left to make sure nothing very strange happens here. So what other UI elements might we have? We might have an element here. Now let's do some color changing. Again, this one I've just moved to the bottom center, so I'm going to go ahead and change the rect transform anchor to the bottom center to make sure that it moves correctly, and it now is retained within the center bottom of the screen whenever I resize my UI. So I'm going to do just a few more things, but really those are the fundamentals of putting your UI together. One thing I will note is that if you make a child object, like for example, if I make this object a child here, then the anchoring is also relative to the parent, which means even if I go ahead and change this anchoring to the bottom right, because it's a child of a parent object, which is not the canvas itself, but a sub object, as it were, this anchoring will be only relative to the center bottom of the screen. So you might think, oh, I can move this over here now and it will be anchored to the bottom right because I've anchored it here to the bottom right. But because it's a child of an object that's anchored to the bottom center, whenever we resize our object, it's not necessarily going to work the way that we expect it to. In this case, it's not working too badly because of how the scaling works. But you can encounter some problems. For example, if we turn off this scale with screen size and go back to constant pixel size, you'll see that even though these are anchoring to the top left and top right, this element isn't. All right, I'm going to put this back to scale with screen size. I'm going to go back to our child and make that a child of the canvas itself. I'm going to change some colors, and whenever you're blocking out stuff, you want to go ahead and choose some sort of saturated colors, usually for prototyping. One thing that you'll often see in like really garish, I would say, UI design is these very over vibrant colors, like these bright reds. And so a top tip just for creating a little bit of an easier look, especially for prototyping stuff, is whenever you're choosing your colors, just make those a little bit saturated and therefore a little bit easier to look at on the eyes. But perhaps we want to go one step further, and instead of just having these basic shapes show the different elements of where our UI are, we want to create little borders and things like that. So let's go ahead and try to create a border with this box as the last thing we try to do. So remember how I was saying that children objects are scale relative to their parents? Well, if we go ahead and duplicate by doing Control D or right clicking on this image and duplicating it, and then we make this new image a child of the previous one, then we can set the transform to scale relative to its parent. In this case, we're going to go ahead and click this little blue arrows up and down and left and right. And make sure you do this on the child version of our object. Now, it's going to be hard to see the difference between these two because they're in the same place at the moment and the same color. So I'm going to darken this one. Now, you'll notice that whenever we have this stretch version of our anchoring, we have changed these values, which was X and Y position, now to these other relative values, left, top, right, and bottom. And these values reflect the distance between these image objects and the object they're parented to. In fact, the reason they're so large is because I think I've parented this particular object here. I've parented it with the wrong image. I've parented it with this image over here. That's my mistake. So I'm going to try and find this one, and so I'm going to parent it to that instead. And now you'll see all of these left, top, right, and bottom values are all 0 because the difference between the edge of this box and the edge of the other box is 0. There's no difference. They're right smack on top of each other, overlapping. So to change that, we're going to go ahead and make these have positive values to offset. So if I go ahead and put in 10 on the left, you'll see it's now an offset of 10, 10 on the right, 10 on the bottom, and 10 on the top. And now we've created this bordered image. Really, we want these to sort of be the opposite way around, don't we, though, in color? So I'm going to make this a lighter color, and then I'll make the border the darker color. There we go, something like this. It's a very thick border, so we can make that thinner by making our offset a smaller value, 5, 5, 5, 5. So we've got the child object, which is stretching. We've got the parent object, which is not. And we could just keep doing this, right? We could create another border. We could create another image that's even lighter colored, like white, and we can make this a larger offset. So we've got like a double bordered object. Whatever visual style you can put together with this, it's up to you. But really the idea is we're scaling children within their parents. And finally, I want to demonstrate why it's really important that you want to not change your scale, but instead change your width. If we change the scale of this X value, you can see that it sort of does scale the whole object, but we've got these big, thick borders on the side, and we've got these little thin borders at the top because we're stretching and scaling the entire image. However, if we instead change the width value here and we expand that, you can see that our border has retained its offset at a totally exact value all around the sides of our object. And so we don't get that stretching, and instead we have a retained border width because our offset is 5, 5, 5, 5 around the edge of our object. We can change the width and scale of, the width and height of our object by either changing these values directly, but the other thing we can do is, just like we've got the scale tool here, which can change the scale with these little boxes, we can also press the next button on, which is T on your keyboard, or just pressing this for the rect tool, which allows us to change the rect transform, which is the shape of the object as width and height. So your challenge for implementing this tutorial is, can you put together the different UI elements? Can you anchor them to the different parts of your canvas? Can you then make sure to change the canvas to match with height or width, mess around with the reference resolution to see what scale your canvas UI should be at? Maybe you want it to be big, that's too big, maybe you want it to be a little smaller. And then finally, your last challenge, if you can do it, it is a bit more tricky, but can you create these children scalars with the offset to create these sort of border effects for your UI elements? All right, I'll see you in the next tutorial. Thanks for watching.